Hi, it is Science Week, so we're all going to be doing demonstrations and experiments all week. This week we're doing a recorded one. You can either watch it or you can do it with me. So first of all, we're going to talk about what we need. My trusty assistant, Miss Grace Olson here, is going to help us. We need a small, clear receptacle. I'm using a small vase. You don't want to use anything too big. We're going to show you why. You're just going to use too much of mom's precious cooking oil. We don't want to do that. We do need some type of cooking oil. So I've just got a jar of canola oil. That'll be fine. You'll need a little bit of water. You'll need a little bit of food coloring. And we've chosen red to do our experiment. And you need Alka Setlzer. Alka Setlzer. Now I don't use Alka Setlzer in my house. I don't do the slang is plop plop fizz fizz. Oh, what a relief it is. That's the old commercials that I grew up with. I don't use Alka Seltzer. So I went to the dollar store and they had these little packs for $1, and there's 4 Alka Seltzer tablets in it. You only need one. So if you have it, great. If you don't, places like the dollar store are easy to get it. And then the other thing you're going to need is a funnel. We're using a funnel because we do not want to make a mess, okay? We don't want to make a mess, and we are pouring oil in particular, hard to clean up, so we are going to use a funnel. So assemble all of your materials, have mom help you out, and we're ready to go. So the first thing that we're going to do, and I'm going to tell you why this works. Now, this is called the lava lamp experiment. We're not really making a lamp, but I'm going to tell you why your lava lamps work. And this is a simulation of why that works. So first of all, if my assistant would hand me my funnel. Hand me my funnel. No? All right, thank you. I got my funnel. So what we are going to do is we are going to take our canola oil and we're going to fill our jar about 2/3 of the way full. All right. All right. And then we're going to stop. And you do not have to fill your lamp simulation all the way to the top. In fact, it's probably better if you don't, because when you're actually getting rid of it, it won't be at the top for you to make so much of a mess. All right. The next thing we're going to do is we're going to take our water. My able-bodied assistant would hand me the water. Thank you, assistant. We're going to add a little bit of water at the top. And you can see that already we have bubbles forming. And we're going to sit and wait for a moment to talk about why we have bubbles forming. Now you can see some of the bubbles are assembled or suspended in there, but eventually all of that water is going to soak to the bottom. Lava lamps work on 2 principles. The first one is density, and the equation for density is mass divided by volume. And one of the things about water is water has a greater density than oil. So if we had equal parts here, we would see things balancing out a little bit differently, but water molecules are more closely compacted. Therefore, the mass of water is more dense than the mass of the oil. We did experiments earlier this year where we had cold water and hot water that we colored, and we were layering them on top of each other. And we determined that hot water floats on top of cold water because the cold water is more dense because the molecules are more closely compacted. The other thing about this experiment is, and I'm going to hold this up because you can see now that as those water bubbles are settling out, we have a layer of water on the bottom that the oil is sitting on top of. So this is talking about the density. Water is more dense than oil. The second reason that a lava lamp works is because of something called polarity. Now, polarity is actually what is preventing from the oil and the water from mixing together. Water molecules are polar because they have a lopsided electrical charge. So H2O is, of course, the formula for water. We have two hydrogen atoms, one oxygen atom, and they kind of form a pyramid. All right. Well, the hydrogen atoms are positively charged. The oxygen atom is negatively charged. And just like with magnets, opposites attract. Well, oil has no negative polarity. So they're nonpolar. They don't have a positive or a negative charge. Therefore, they're not attracted to other water molecules at all, whereas water molecules are attracted to one another. All right, so we all know that a lava lamp has all this really fun stuff. So if my assistant would hand me the red food coloring, the next thing that we are going to do is we're going to take a few drops of red food coloring and we're going to drop them into our mixture of oil. And you're going to see that they drop, and at first they sit on top of the water and then they begin to sink down. But they aren't mixing. The oil is actually encapsulating them. So I'm going to pick this up and show you that what we have here at the bottom are a bunch of little oil. Now, the longer we leave them to sit in there, however, the more they're going to leak out. So what we're going to do now is we're going to take our Alka Setlzer tablet and we are going to drop it in one bit at a time. And what's going to start happening? Oh dear, we have colored droplets going up and down and up and down. Some of them are lighter colored as the bubbles will mix. Now, with a real lava lamp, what tends to happen is it's actually frothing quite a bit. So what happens with a lava lamp is, as we know, when there is heat, water molecules separate. They go farther apart. And what we have is a convection current. So the heat source is at the bottom of the lamp. So that water is heating up. Those colored drops are heating up. They're floating to the top as the molecules move farther apart. Of course, as they get to the top, what happens? Just like the mantle of the earth, the materials start to cool down. And when they cool down, those molecules contract again and they become heavier and they drop to the bottom. And just like this, let's get another one going here. You get this constant cycle of up, down, up, down, up, down. So I'm going to have my little assistant here drop another one in there. And you can see we've still got bubbles, colored bubbles that are going to circulate for as long as we have activity. Of course, what's causing this to bubble is the release of carbon dioxide. So when the Alka Setlzer mixes with the water, it's releasing CO2 and we're getting those bubbles forming, right? It's actually quite pretty. I wonder what would happen, able assistant, if we added some blue drops. Would you like to find out? Okay. Would you like to carefully drop a couple of blue drops in there? First of all, let me, 1, 2, 3. All right. And let's drop another bit of piece of Alka Setlzer in there. And now, if you're an art aficionado, you would think that maybe this would form purple as they mix together, but I actually see that the blue, there we go. We've got purple drops going up one side. Woo! Very exciting. All right, so the scientific principle for today for our I guess a demonstration of how a lava lamp might work without the heat is the principles of density and polarity. Remember, density is mass divided by volume. And the polarity, water is polar because it has 2 hydrogen and 1 oxygen atom. Opposites attract, so water molecules are attracted to one another. Oil is nonpolar. It doesn't attract itself to water. Therefore, they don't mix, all right? It has to do with the density of water and oil and the polarity of the molecules. Here endeth the lesson for today. It was short and sweet, but I hope you had fun. And, you know, you can dazzle your little brothers and sisters with that. Tell them you know about density and polarity. All right. Okay. See you tomorrow.